editing and you share the video with me later. I'll put it in YouTube. Okay.
Yes, sir.
Okay. So we have been discussing the mechanics of metal cutting. So under that, we have seen what is cutting ratio. That is the first thing. What is cutting ratio? Cutting ratio. It is the simplest question in this topic. So you are not at all following. That is not. That will not help you in solving any of the problems. So cutting ratio is T0 by Tc, uncut chip thickness divided by the cut chip thickness, represented with R. Now, what is the symbol for shear angle?
Phi.
Yeah. Okay, we are using phi symbol, but that phi, shear angle phi, is different from the principal cutting edge phi. Okay, both are different. That you have to understand. So we have, what is tan phi? Tan phi is equal to R cos gamma by 1 minus R sin gamma. Okay, these are the basic things. So without which you cannot solve any problem in this mechanics of metal cutting. And we have seen the relation between R and phi in that way, and we have seen the relation between shear angle gamma with various velocities also. We are drawing the velocity diagram. And after that, we have seen the Metzen circle. So in which you have seen the relation between the measured forces. What are the measured forces during cutting, or measurable forces otherwise? Forces that are measured using dynamometer.
Friction force.
No. You cannot measure friction force directly during machining operation. You are measuring the cutting force and thrust force. Okay, horizontal component and vertical component. Okay, if you are considering this pure orthogonal. But anyhow, this horizontal force, okay, that is thrust force. The force that is coming, if force acting in the downward direction is Fc. And if you consider the horizontal plane, okay, during turning process, if you consider one horizontal plane, so on that horizontal plane you have Fx and Fy. Okay, along the axis of the workpiece, one force is acting, and perpendicular to the axis, and okay, it will be horizontal at the same time. One force is acting, that is Fz. Resultant of Fx and Fz is Ft, that is thrust force acting on the cutting tool. Now the force directly acting in the downward direction is the cutting force. Okay. And of course, we have seen the relation between friction force, normal force, shear force, okay, and normal force to the shear plane. So those relations we have seen, and we have seen how to draw them in a circle that is nothing but a merchant circle. And using merchant circle, we have derived one the relation between these angles, the shear angle, rake angle, and friction angle. Okay, for the minimum power consumption. So that is 2 phi plus beta minus gamma is 90 degree. Okay. And we have seen the modified merchant theory. Okay. 2 phi plus beta minus gamma is equal to cot inverse k. So there you have considered tau s is equal to tau so plus k times of sigma s. So from that you have got that relation. Another relation is Lee and Schaeffer. Using Lee and Schaeffer theory, phi plus beta minus gamma is equal to 45 degrees, pi by 4. So that was one more relation. And yeah, those are the things I think we have covered so far. Now we'll look at some of the numerical problems. I'll discuss one small thing that we missed in the last class. Okay, maybe tomorrow. I just record it now only. That is only just by a careful observation of the geometry, you will get that relation anyhow. But we'll do it tomorrow. So now let us solve few problems related to mechanics of metal cutting. So all of you read this problem. In an orthogonal cutting operation, the tool has a rake angle equal to 15 degrees. So what is that? Rake angle means? What is the symbol we are using?
Gamma, sir.
Yes. So try to note down the given data in the known notations. So gamma is equal to 15 degrees. If we strictly talk about this, we can write gamma O also, but both are same. We are talking about orthogonal process. Gamma is 15 degrees. Chip thickness before the cut. What is the symbol?
T naught.
T0.
Yes. T0 or T0 whatever is 0.3 mm. And the cut yields a deformed chip thickness is equal to 0.65. What is that?
TC, sir.
TC. That is chip thickness. Now calculate the shear plane angle. So that is, what is that? Shear plane angle means phi. Shear strain for the operation. So what is the symbol we have used for the shear strain? We have used zeta. It varies from textbook to textbook. Okay. Now if you want to find this tan phi or phi, so that means what is the formula we know? Tan phi is equal to r cos gamma divided by 1 minus r sin gamma. Now gamma is known, but we don't know r. Now can we find r? What is r?
TO by TC, sir.
TO by TC. Now Just calculate and tell me what is this value. How much is this? You have to do just sitting.
Sir, 0.4615. 0.461.
4, 6. Okay, we'll start with 2 digits. So 4615. Now you can find tan phi. So it is a 0.46 into cos 15 degrees 1 minus 0.46 into sine 15 degrees. Now find out this value. This is tan phi, remember.
Tan phi is equal to 0.505.
0. Find, okay, let us take it. Now what is phi?
Sir, 26.85 degrees, sir.
Okay, this is one of the very simple problems. Directly data is given. Just you should know the equation and substitute. Okay. Now let us see this. In a turning operation, spindle speed is set to provide a cutting speed of 1.8 meter per second. So what is that 1.8 meter per second?
Sir, V, sir.
V.
Cutting speed.
Yes. The feed and depth of cut are 0.3 and 2.6 mm. So feed, okay, we can represent that with F is 0.3 mm. And depth of cut, maybe you can use small d, is 2.6 mm. The tool rake angle. So what is rake angle? Rake angle is 8
Gamma,
degree. Gamma 8 degree. After the cut, the deformed chip thickness is measured to be 0.49 mm. What is that?
TC.
TC. Now determine the shear plane angle. So that is phi. Shear strain, that is zeta. In the previous case, have they asked for zeta also?
Yes, sir. It was asked
Yes, sir.
So, okay, you have to use the same process. What is zeta, formula for zeta?
Cot phi plus tan of phi minus gamma.
Cot phi plus tan of phi minus gamma. Okay. So in the previous slide, so we know phi, we know gamma also. So using that, you can find zeta. Okay. So now this is zeta. Now the third one is material removal rate, MRR. Use orthogonal cutting model as an approximation of the turning process. So this is orthogonal turning process. That's it. So we can apply the formulas that we have learned in merchant theory. Now we have to find phi. So for finding phi, we know that tan phi is equal to r cos gamma divided by 1 minus r sin gamma. So we know gamma. Now for R, it is TO by TC. Now we have TC directly. Do we have TO to find R?
No, sir, we don't.
Yeah, it is not directly given, but it is indirectly given. Okay. So,
The depth of cut, sir.
no, it is feed. Feed. So how, if you understand the diagram, just for your understanding, I'm drawing this. Okay, this is a cutting tool here. Now let us say in one turn, it is going up to this. Okay, it is removing this portion. In the second turn, it is removing the material of this much thickness. Okay, in other words. So once it is removed, then it is going like a chip. Okay, its thickness is increasing. But otherwise, from here to here, that is nothing but the thickness of the chip in pure orthogonal turning process. Okay. So
So
T1
in
F
that
are
case,
hmm,
in that case, like depth of cut will be equal to the thickness. No, sir.
no. See, you
In
consider
that case,
the
that ratio will increase.
hmm,
Sir, I mean, like if you use depth of cut, it will be useless, sir, because that ratio should be less than 1.
yeah, logically that is also correct. Okay, 2.6 by 0.49 anyhow is more than 1. So that is not okay. Your D will not be equal to TO. TO is always less than TC. That is always true. Okay. So logically, if you think that is also correct, and if you understand this carefully, the mechanism of material removal. So you are removing like this material. Okay, in one turn you are removing one layer in this fashion. Okay, this you are cutting into this. So once it is coming out, then you have to understand the shape of the chip. Understand? Once it is coming out,
Yes, sir. Understood.
okay, then you see that is the thickness. But of course, that is cut chip thickness, uncut is this. So we'll write this as 0.3. TO is nothing but F, 0.3 by 0.49. So what is that R now? Value.
Point 612, sir.
Okay. Now you can find a tan phi. What is tan phi? Let's find this side.
0.662, sir.
0.662. Then what is phi from this?
.50, sir, degrees.
So 33.5 approximately. So we have found that phi that is over. Now find zeta, that is a shear strain, that is cot phi plus tan phi minus gamma. So find out this.
Sir, 1.98, sir.
One point 1.98. Okay, it will be on. Okay, it varies slightly after the
Close
degrees.
to 1.99, 1.987, sir.
Yeah, okay. Fine. 1.99 we'll say. Then what is MRR? What is MRR by definition?
Volume of metal removed per unit time.
Yes. So how will you get the volume of the material? Of course, I have already shown you this formula directly. It is nothing but VFD. That's it. Understand? You are getting the this F means the thickness, okay, depth and velocity at which it is moving. Velocity is nothing but length by time. Okay, length of the chip by time. Understand? So, what is this? MRR. So here,
1.404.
1 point.
1.404
Yeah, it is in meter cube. You convert it to mm cube. Okay, 1.404 mm cube per second. Okay. Now, how MRR has become VFD? Okay, you have to understand whenever no information is given, or we cannot find any information regarding the principal cutting edge angle. Okay, that is assumed to be 90 degree in pure orthogonal cutting. Okay, that means we are doing some operation like this. Okay, then speed, feed, depth of cut. Understand? Depth of cut is up to here. Feed is anyhow coming here. Okay, that is one area. And what is its length? Okay, so then that will give you MRR. Understand? So that's it for this problem. Now have a look at this. During turning a steel rod of diameter 160 mm. So diameter of the rod that you are turning is 160. At speed 560 RPM. So N is equal to 560 RPM. Feed. In fact, they have given feed rate. Okay. And feed only, mm per revolution. And depth of cut 4 mm by a ceramic inset of geometry. Okay, inset geometry is given here. It is orthogonal turning process. So from this you can get some information. What is the information you can get? Can you say something about any angle? In fact, there are 6 angles. What is gamma? 0 degree. Okay. What is phi? Phi from this. principal cutting edge angle 75 degrees, nose radius 0, that anyhow is not required for us. So you have to clearly understand that this is principal cutting edge angle, not shear angle. So there is this confusion sometimes because we are using same phi for both.
Sir, is it an RS system or ORS system, sir?
This is ORS. ORS. Now the followings are observed. FZ. FZ. What is FZ? In our represent, we have not used FZ in MC merchant circuit diagram. We have not used FZ. So it is a notation used in some other textbook. I have shown you one diagram in the last class itself. Fz is the force in the downward direction. That is nothing but Fc. 1600 Newton. Okay. Fx is 800 Newton. Now, what is this Fc, Fn? Okay, you should understand this. Is it clear how we have written Fz and Fx? It is anyhow directly given, but where they are acting during cutting process, okay, you should be very clear about that. Just in case, I should go back and show you, otherwise. Okay. Okay, here you observe this figure. First figure, PZ. PZ is nothing but Fz here. Okay, force is represented with PZ here. So that is in the downward direction, that is cutting force. Py and Px are there. So the resultant of Px and Py is the thrust force, that is Pxy. Okay. So we have seen the relations also here. Px is equal to Pxy sin phi, Py is equal to Pxy cos phi. So this is the thing. So, okay, like note down this. I60 RPM. This 5, whenever you are writing, better to write it here. Okay, this is principal cutting edge angle. Principal, I think. Okay. Otherwise, we may forget and think that this is shear angle. Okay, better to write. The followings are observed. Fz now, according to our notation, it is Fc 1600. Fx, there is no change, 800 Newton. And the chip thickness is 1 mm. Chip thickness means after cutting only. Tc is 1 mm. So determine with the help of merchant circle diagram the possible values of F, N, normal force, friction coefficient, shear force, normal force, hour required, or cutting power PC, specific energy consumption. I'm not given any symbol, we can write specific energy consumption. So we have to somehow try to draw this merchant circle diagram with the given information. So FC is known, Fx is known. In merchant circle diagram, what are the vertical for two measurable forces? Directly measurable forces. Please respond. FC and FT, isn't it? FC and FT. Now, what is FT? Do we know FT here? Can we find FT?
FT is given, sir. Fx.
No. Fx, resultant of Fx and Fy is FT. Okay. Resultant of Fx and Fy, that is Pxy in the diagram that we have seen, that is Ft. So here we know this okay, principal cutting edge angle 75, and I have just shown you that this is Fx by sin phi, or Fx is equal to Ft into sin phi. Okay, where this phi is equal to principal cutting edge angle. So tell me, what is this value? What is this value?
828.22.
So approximately 828 newtons. So once you know Fc and Ft, okay, so you can also find of course, resultant force anyhow, not from diagram itself you can find. So you take some scale, okay, let us say, we can say 1 centimeter is equal to some 400 Newton scale for our convenience. So that means 1600 will be 4 centimeter, and based on this, based on that, you can convert Ft. It is approximately 2 centimeters, more than 2 centimeters. You find out the exact value itself directly. Okay. Now all of you draw this in your white sheet, if you have sheet or book. Draw this horizontal force, 4 centimeter Fc. Okay. Then Ft also you draw vertically here at this end. Now you can join these two ends and find the resultant force R. Okay. Now, can we draw any other force? Acha. Gamma 0 degree, is it correct? What is this angle? In ORS torus system, what is the first angle?
Inclination angle, sir.
Yeah. So by mistake I have written this. This is lambda in fact. So of course we are not interested in lambda anyhow. So gamma is minus 10 degree. Okay, this is important. Otherwise we will commit a mistake. So gamma is minus 10 degree. So if you draw a vertical line here, if it is positive 10, we'll draw it in this direction. Okay, towards this. If it is negative, in this direction. Something like this. Isn't it? So you take that minus 10 or 10 degrees and draw in this direction. Okay, and of course, before that, you take the center of this resultant force R and draw a circle. That circle will definitely pass through these things. Something like this. Okay. So now you draw this, take this angle and draw a line with the minus 10 degree in this direction. Okay, because my circle is not very clear, so it is looking like that. So all of you do this in your notebooks. Then obviously this end can be joined with this wherever it is. Now what is this? F. This is N, isn't it?
Sir, one doubt.
Hmm.
Sir, regarding the negative of gamma, like we should take anti-clockwise or clockwise from the vertical.
So this is vertical. If the gamma is positive, it will show in this direction. If it is negative, in this direction.
Okay, sir, understood.
So F, yeah, all of you draw this in your notebooks and find out what is F and what is N. Mu also you can find. F by N is nothing but mu. So tell me these three. You can just measure it and multiply with the scale that you have taken. Suppose if you are getting 1.5 centimeter, it will be 600 Newton, something like that. From the diagram, anybody? Tell me the values for F, N, and of course F by N is mu. Is anybody doing? It is 700 Newton. Okay. So normal force is 1760 Newton. And you can find the mu value, division of these two, F by N is 0.43. Now how to find this Fs and Fn? So Fs will come in this direction, upward direction. We should know phi, that is shear angle. Now can we get a shear angle? Can we get shear angle? For getting shear angle, what are the things required? Gamma is required, which is given, and we should know R value, TO by TC. TC is available. What is TO then? What is TO?
So like last
F
column we
value.
can take 0.32, sir.
That is the thing you have to observe. It is not directly equal to feed here because we have this principal cutting edge angle here, that is 75. The previous case it was not mentioned and we assumed that that is 90. Okay, if it is not given, you would take it 90. But here it is given as 75 degrees. Okay, understood. So this is if you say instead of 75 it is 5. Or otherwise you can remember this in this fashion. So TO is F sine phi. TO is F sine phi. This is F, this is phi. Thickness of the chip. Okay, that means it is something like this. Shortest distance between these two sides. Okay, that is thickness. Okay, so that is F sine phi. Previous case, y it has directly becomes phi is 90 degree. So this is the exact thing. Okay. Now you find out what is TO first, then find out R. Or otherwise you can directly write this as TO by TC, which is equal to F sine phi. TO. Okay, now find out this. How much is this? R value.
So TO is 0.309.
That's it. That is R because TC is 1 only. Okay. So 0.309.
309.
So that is our R. So from that you find out phi, tan phi. Because TC is anyhow 1. So that will be that. Tan phi equal to R cos gamma by 1 minus R sin gamma. Now from this, okay, tell me what is phi.
So 10.5 is approximately 0.29, sir. 2.88, 2.9, sir.
Yeah, find out that phi tan inverse of that.
— 16.06 degrees, sir.
0.6. Okay, I have got 2.7. Okay, it will be fine. Okay, approximately that value. Now, once you know, you have to be very mindful and careful while you are using this phi. Okay, this is shear angle. This is principal getting examined. We are using two phi's in the same problem. Ideally, you should use some other notation, but because okay, we are more convenient with this, we are using this. So shear angle phi is this. So you take that 16.27 degrees and draw a line like this. So that is Fs, that phi value. And of course, you will join this. You will find, sorry, not here. Okay, this. So that is Fn. So we have found this Fn mu Fs Fn. Okay, if you measure them and take those values. Otherwise, also using formula analytical method, okay, you can find. We have expressed Fc in terms of, sorry, Fs in terms of FCFT. So that will also work. But this is much easier if you construct MCD. Directly you can measure and write. Now PC. PC is cutting power. Now what is cutting power? Cutting force into cutting velocity. So what is FC? FC anyhow we have 1600 into V. How do you get V? D, N are given. So pi d n by 1000. Okay, because D is in mm. So find out PC.
So 1000 into 60 should be into 60 also, sir. RPM given, sir. Minutes.
Okay. Okay, you convert it into 60 also. Rotation per minute. So per minute means into 60 you will get. Yes. So what is PC then?
— 7506.31 over.
Okay. Whatever you are getting, it is approximately as per my calculation because based on number of digits we are taking, it will slightly vary. So it is approximately 8 kilowatt. Okay, we are taking in kilowatt. So that is PC. Now what else? Specific energy consumption. Okay. Now what is a specific energy consumption? How to find that? It is FC by TO into F. It is amount of energy required for unit material removal. Energy required means you can. I have written the final formula. Otherwise, energy required means FC into V, that is PC only, by unit volume removed. Okay, so that is V into TO into F only. Okay. So V gets cancelled, so it is FC by TO into F. So calculate this and see what is the value. How much? FC by TO into F. TO we should have here. It is 1250 Newton, okay, mm per mm cube. So Newton meter is anyhow what? Here we are showing Newton mm per mm cube. Okay. So this is how you solve problems or some of the problems related to mechanics of metal cutting. Okay. So if possible, we will see one or two problems tomorrow and go to next topic. Because there are many different problems in this category. You can take any textbook and solve some problems. Okay, this is very, very important. So that's all for today. So anything to discuss? And Kalyan, are you
Yes, sir.
online? Have you recorded the meeting?
Oh, yes, sir. I will share this.
Okay, share it with me. And meanwhile, the student representatives can ask the administration to provide this recording option in the Google Meet. I don't know, suddenly it has disappeared. So it should be under the control of institute, okay, computer center or the computer admin, whoever is there. So you can bring it, take it to the